In this video, we're going to identify different forms of symmetry. These include translations, rotations, and reflections. First, let's go through translations. In a translation, each point in a figure slides the same distance in the same direction. The way I remember it is that translation has an SL and slides has an SL. Usually you're given a direction, such as 2 places to the left. Let's go through a translation problem together. This says to translate the following triangle 2 units up and 3 units right. We're going to take each point and go up 2 units and then to the right. Let's start with the Y. We're going to go up 2 units and then to the right 3 units. Now we have our new position for our Y. When we plot the point, we're going to put this little dashed line in the right-hand corner. That means Y prime. Now we can do the same thing with point M. We're going to go up 2 units and then to the right 3. Notice that it landed on the same spot as G. That's okay. Now we have M prime. The last point to move is G, so we need to go up 2 and to the right 3. We can plot that as G prime. The final step is to connect our dots, and we can see the purple image is the translation of the green image. The next type of symmetry is called a rotation. A rotation is when an image is rotated around a central point. Notice that the S is rotated around the origin. It can be rotated a certain amount of degrees. In this case, it was 180 degrees. If it had rotated 90 degrees clockwise, it had been in quadrant 2, and if it had moved 90 degrees counterclockwise, it'd be in quadrant 4. A full rotation is 360 degrees. Again, a rotation can either be clockwise or it can be counterclockwise. Let's go through a rotation problem together. This says to rotate the following triangle 90 degrees counterclockwise around the origin. This means that we're going to go opposite of clockwise. We're going to rotate around the origin in the middle, and we're going to rotate 90 degrees, so we're going to go to the quadrant to the right. So to do this, it helps to count from the origin. Let's start with point B. Point B from the origin along the x-axis is 1, 2, 3, 4 units to the left. Then it's 1 unit up. We're going to follow that same pattern as we find B prime. So to rotate, instead of moving on the x-axis, we're going to go 4 units down on the y-axis. So we're going to go 4 units down and 1 unit left. This new point is B prime. Now let's move point X. Point X is 1, 2, 3 units along the x-axis, and then down 2. To find its new position, we're going to go down the y-axis, 3 units. We need to then go 2 units to the right, so we're the next quadrant over. And now we have X prime. The last point to rotate is point N. Point N is 1, 2, 3, 4, 5 units over on the x-axis, and then 1, 2, 3, 4 units down. So we're going to go 5 units down on the y-axis. We need to go to the right, and we need to go over 4 units. And now we have N prime. Lastly, connect the dots, and we have our rotated triangle. The last kind of symmetry is reflection. Reflection is also known as line symmetry or mirror symmetry. One half of the image is a mirror of the other. Look at the pictures below. On the butterfly, the left side is a mirror image of the right side, and the green T is a mirror image of the red T. The 2 lines these images are mirrored over are called the lines of symmetry. Here's an example of a reflection problem. It says to reflect the following image over the y-axis. That's extremely important because that's what's going to tell us what to flip over. To find the new points, we're going to count how far away we are from the y-axis from each point. W is 2 units away from the y-axis. So we're going to move 2 units in the other direction on the other side of the y-axis. And now we have W prime. We're going to do the same thing with point S. Point S is 2 units away. So we're going to go 2 units on the other side of Y. And we have S prime. We're going to see how far P is and P is 4 units away, so we're going to go 4 units on the other side of the y-axis, giving us P prime. And then finally we have I. I is 1, 2, 3, 4, 5 units away from the y-axis, so on the other side we're going to go 1, 2, 3, 4, 5 units away. And now we have I prime. We have our new image reflected over the y-axis. If we were going to fold this coordinate grid over the y-axis, the two images would land on each other.